And with that, you now know enough about Git to use it for your project. So I'll continue to discuss a few more topics, but we'll probably not have time for hands-on exercises related to this. So please refer to the handout for more examples. And if you have any questions, please don't hesitate to reach out to us at helpdesk@chpc.utah.edu. The stash is a place where you can store your changes or stash your changes, which are your working tree and your index, so anything that's not been committed yet. So this is useful to clear out any changes that you don't need right now, but that you may need at some point. So for example, if you need a clean working tree or index right now to do something like pull changes from a remote repository, but you might want to come back to your changes later that you have not committed yet. You could also just make a new commit on a new branch and then come back to that branch later if you wanted to incorporate those changes into a different branch. And again, I have some examples of this in the handout. A submodule is another Git repository that's included as a part of your repository. So this is the preferred way to refer to other projects because it allows you to reference specific commits in another project without including the contents of that repository in your own. So you're not duplicating the content from another project, which would be all of the commits and everything, right? You're just saying, I rely on this part of this other project, and this is where you can go find it. Git Large File Storage, or LFS, is an extension of Git that's used for versioning large files. These are things like video files, very large images, large binary files usually, but really any large file. And it uses what they refer to as text pointers inside Git. So the actual files are stored elsewhere and there's just a reference to them inside of Git itself. And this is used to keep repositories relatively small. So one reason why you might do this is because Git stores the whole file every time you make a change to it. So if you have a really large file, let's say 20 gigabytes, and you have 5 revisions, that's 100 gigabytes that your users would have to download, and most of them probably don't care about the 80 gigabytes of old content. They only care about the most recent version, right? Now, when you're using Git LFS, it's an extension of Git that is a bit more intelligent than just trying to download everything all at once. And by that I mean, if you try and access one of these previous versions of this 20 gigabyte file that you hadn't downloaded initially, Git would know to go look for it at that point and to download it. So it's just sort of hiding the fact that it doesn't actually have that file downloaded. Now, some hosts like GitHub will actually reject larger files. So as of fall 2024, GitHub will block any files larger than 100 megabytes, and it will warn about files larger than 50 megabytes. So you may actually need to use Git LFS depending on the nature of your project. Tags allow you to give a name to a specific commit. So usually this is a version number, like I have this example here, v1.2. And this is used to annotate specific commits. So your history of your project can get pretty long, right? If we go look at this again, there's probably hundreds, if not thousands, of commits in this project's history. And having defined points where you can go back and look and say, this is a specific release of this project is very useful. So let's go back to this repository here, this random one that we found. We can see that they are in fact using tags. So they have like a version 0.2.1, and that's sort of just a naming convention. And so this is a defined point in time where you can see this was released 3 weeks ago, but there are changes that are more recent, like 3 days ago. Really, these tags are often used for stable versions of projects. So when they know that everything is working as intended. Now there are also a few different files that are commonly added to repositories. One of them is gitignore, or .gitignore. This allows you to designate files as intentionally untracked. So when you do things like git add everything in the directory, right, or git commit everything, it won't actually add these files. So this is useful for things like intermediate files. Like I have this example of tech documents where you have intermediate files like log and auxiliary files. This is also applicable to things like object files and executables as if we were working on a compiled language. And this will just ignore all of those when you run commands like git commit with all or git add with all. And this can make your life easier because you don't have to manually exclude all of these files or manually include all of the ones that you don't want to ignore, if that makes sense. You can also use a different file. You can configure core.excludes file to point to this different file. And that way you could have like a global list of files that you just aren't interested in keeping in your repositories. .git attributes is another file you can add to a repository that lets you specify the attributes of specific files. So for example, you can identify certain files as binary files, and you can change the behavior of things like diff. So in .git/config, I have an example here where I set up a diff called pandoc, where I convert text using the command pandoc to markdown. So this is a command that will convert different file types, and I'm converting it to markdown, which is like a plain text file type. And then I can specify in git attributes that for any docx file, it's a binary file, and I want to use this pandoc diff type for any comparisons between files. So then I have this example here where I'm using Microsoft Word, which is normally not great with Git because it's sort of an archive file of all of the content in your document, but it's converting it to Markdown when I run this diff command, so I can compare different versions of this Word file. And while it may not be exactly the content in here, right, it's being converted to Markdown, it really gives you an idea of what's changed between the versions, which is very helpful. Now, a README file tells potential users and contributors about your project. This is often written in Markdown or restructured text, and it allows you to add headings, links, tables, images, and other features. And this is actually what's displayed on the homepage of a project on sites like GitHub and GitLab. So this is a pretty complicated README file. Actually, we looked at this briefly earlier when I was editing it, but this is just a Markdown file, and someone's written some HTML and some Markdown. So they have like headings here, and here's a link. Here's an image. So this is just a way you can tell people about your project, and it's sort of a web page that describes your project and how to contribute to it, how to use it, things like that. So we definitely recommend including a README in every project because it tells people about your project and how they can use it. A license file will tell users the conditions under which they can use, redistribute, and even commercialize the contents of your project. Potential users or contributors may avoid your project if the license is unclear because they want to be sure that they're going to be able to continue using it going forward. So we recommend including a license in every project. We could go through and look for one here. There is indeed a license file here. You can see this one is the MIT license, which is a very common open source license. So with that, we can conclude our presentation for today. We've really only just scratched the surface of Git today. There are many other more advanced topics that we don't have time to cover in detail, but the material we covered today may be sufficient for your workflow. You may not even need anything else. And you should now be able to understand the more advanced topics if you search for them on the internet or if you encounter them naturally. So we've made a lot of progress. If you have any questions about this, please don't hesitate to reach out at helpdesk@chpc.utah.edu. Thank you.